So we'll be looking at the density of some copper coins. Our title of the lab is density, and the aim is to determine the density of the copper coin. That is important because that should be answered in your aim at the density of the copper coin. Some of our instruments are the micrometer screw gauge, the vernier caliper, and the electronic balance. We're expected to record our first set of readings, the diameter of 3 coins in our first table in millimeters, and then we'll find the average as well. Please note that the diameter will be measured in millimeters. We need to convert that later on into centimeters. We'll come up on our second table. I will be doing a little bit of variation. We'll be using 3, 6, and 12 coins, finding the mass, the height, calculating the density, as well as the volume. So we'll be looking on some calculations after this. We'll show you how we would actually calculate our radius, our volume, and our density. Afterwards, we're going to look at some source of errors in another video, as well as the precautions we should take. Notice that we're saying that your conclusion should be answered in your aim. So you should say the density of the copper coin was found to be, so on and so forth. Let's begin. This video, we're looking on finding density of these coins. The instruments we'll be using are, this is our micrometer screw gauge. Based on the instructions, we'll be using that to find the diameter. This is our vernier caliper, and the other instrument we'll be using is our electronic balance. So we're gonna go through the procedure to find the density of these so-called copper coins. So here we're looking on to determine the density of a copper coin, and for step 1, find the diameter of a single coin. So we have selected 3 of our coins, and I found out my nails want to be done as well. There's 30. And we'll be using the micrometer screw gauge. Now the micrometer screw gauge will say that we'll actually have a 0 error. So before we take any measurement, we need to find the 0 error, and we'll, depending on the error, we'll actually add or subtract this value from each of our diameters. So we're going to take our first reading, and that is 14. It's in there on your thimble, and that is in line with 85. So you'll express that as 14.85 millimeters. Now, looking on our second coin, let's see our reading as well. Our reading is also 14, but that's 14.91 for our second coin. We'll be doing another coin, and then we'll be taking the mass of the 3 coins. So here is our last coin. We're gonna look as well. Now this is 14.85 millimeters as well, and then we're gonna move on to find the average diameter of the 3 coins. We found the average of the diameter of the coins to be 14.87 millimeters. Now we need to find the average radius. I went ahead and found the radius and the diameter of the coins. We divide the diameter by 2 to find the radius, and we kept everything to 2 decimal places. We're gonna go ahead and fill out our second table. We'll be taking the mass of 3 coins. We just drafted a table. That's our table. We will find the mass of 3 coins, so we'll be using electronic balance. One thing when you're using electronic balance, you ensure to 0 the balance. Good. Then you put the 3 coins on it. It doesn't matter if you start the 3 coins on together or they're apart, the mass will be the same. So we have 7.22. Sometimes it will fluctuate. we'll go with 7.22 grams. We'll be taking the height of the 3 coins. So these are our 3 coins. We're going to stack them together like this. This is going to be our vernier caliper, and we're putting them into the vernier caliper jaws, and we're going to close it shut. Notice that there are 2 scales. We'll be reading the scale at the bottom. This is the scale at the bottom. Normally there should be a knob up here to tighten the vernier caliper. That seems to be missing. So, but we're going to take the first reading from here, and we're going to move up to the top, and at 0.5 centimeters. We're looking for where the top scale is in line with the bottom scale, and we're taking that as our second reading. So let's hold that tightly there, and we're seeing that to be in line with the third bottom stroke. So it's 0.53 centimeters. It requires us to calculate the volume. Since we form a cylinder, I'm going to go to the next page and give you a sample calculation of calculating the volume and the density. The volume of the cylinder we've made is equal to pi r squared. We're going to use 3.14 for pi. We've already got our radius, but there's a problem. We need to convert from millimeters into centimeters because the micrometer screw gauge will be giving our values in millimeters, but our vernier caliper will be giving our values into centimeters. Therefore, we're going to convert the 7.44 millimeters into centimeters. We went ahead and fill out the table, and this is what we got.